Hello students, today we are going to learn a concept of engineering mathematics, that is the Cramer's rule to solve the system of linear equations. Okay. So let's start. Suppose this is a system of linear equations. You can see three equations are there: 3x plus 4y plus 3z equals 2, 2x minus 6y minus 3z equals to 5, and 7x plus 3y minus 4z equals to 6. These are the three equations, and you can see three unknown variables are there. Okay, so we can solve this, means what are the values of x, y, z which will solve these equations, that we have to find out. Okay, so we can find this by the help of Cramer's rule. Okay, so that these equations can be satisfied by values of x, y, and z. Remember this thing, that I believe that you know how to find the magnitude of a matrix in case there is a matrix is there, or determinant, matrix and determinant form, how to find the magnitude of that determinant. I believe that you know that. In case you don't know, then you can learn that first. Right now, I believe this, that you know how to find the magnitude of a matrix. Okay, so this is the system of linear equation, and now we are going to apply Cramer's rule. It is very easy to understand. First of all, write these equations in this matrix style. You can see that the coefficient of x in first equation is 3, in second is 2, and in third it is 7. So write 3, 2, 7. Similarly, and the coefficient of y in first equation is 4, so 4, and in second equation it is minus 6 and 3. Like the same for coefficient of z, 3, minus 3, and 4. So this is our left hand side matrix, and in right hand side it is 2, 5, 6. So this will be a column matrix 2, 5, 6. So I have written the letters in red. Okay, now what you have to do is find the magnitude of this left hand side matrix, means taking it in determinant form and find the magnitude. Okay, let the symbol of that magnitude is del. Remember this thing, that must not be 0. In case it is coming out 0, you cannot apply Cramer's rule. Okay, so let it be del, and here I have already found, I have calculated the magnitude of this matrix, that is 191. The first job you have to do this, write the system of linear equations in matrix form like this, in this style, and then find the magnitude of left hand side matrix. Now what you have to do is that in the right hand side you can see this matrix 2, 5, 6, which is the right hand side of these linear equations. Okay, now this column, this first column which contains the coefficients of x 3 to 7, replace this column with this right hand side matrix 2, 5, 6. Okay, so you will get this. In place of this 3 to 7, just write this 2, 5, 6. Rest of the coefficients will remain same, means of y and of z. So this. Now what you have to do is that find the magnitude of this matrix now. Let it be del x. Okay, so after finding matrix, I have found it that del x is equals to 2 to 7. In case you are finding the magnitude of this matrix, it is 2 to 7. Now next, do the same job with this second column, means replacing this second column with this right hand side matrix 2, 5, 6. Okay, so here it is. In place of coefficients of y, I have replaced it with this right hand side matrix. Now find the magnitude of this matrix. Okay, so let it be del y. So del y, here I have found it, it is equals to minus 101. Now do the same job with this third column, means replacing the coefficients of z, 3 minus 3 minus 4, return this right hand side matrix values. Okay, 2, 5, 6. Now find the magnitude of this matrix. Left hand side matrix, let it be del z. So here I have already calculated, that is del z equals to 35. So write it like this. So del means the magnitude of this matrix, means no replacement is done, that is 191. And del x equals to 227, we have found it. Del y equals to minus 101, and del z equals to 35. Okay, now just you have to do this thing. To find x, just divide del x with del. That's it. That is coming out to be 1.18. Similarly, to find y, that will equals to del y upon del. So you can divide it, that is equals to minus 0.52. And to find z, that is equals to del z upon del, that is equals to 0.18. Now you can put these values in these three equations, you will get the correct RHS, means in place of x, put this 1.8, 1.18, in place of y, 0.52 negative, and in place of z, 0.18, you will get 2. Similarly, in case you are putting these three values in this second equation, you will get 5, and in the third equation, this is 6. So that's all with Cramer's rule. By the help of this example, I tried to make you understand about how to solve the system of linear equations by the help of Cramer's rule. Second thing is why I told that this del must not be 0. In case this del comes out to be 0, then all these three will become infinite. So that will not result in any solution. Okay, thank you.